Welcome to Lecture 2, Formation of Ordinary Differential Equations. We can form a differential equation by eliminating the constants in an equation. But before we do that, let us define what is a primitive equation. A primitive equation is an equation with the least number of essential constants. Essential constants are a set of constants that cannot be replaced by a small number of constants. Examples of primitive equations. Suppose we have y equals to ax plus b. This is a primitive equation with two essential constants, a and b. Another one, y equals to a exponential x plus b. This one is a primitive equation with two essential constants, a and b. Another one, y equals to ax squared plus bx plus 2. This one is a primitive equation with two essential constants, a and b. Another one, y equals to a exponential bx plus c. Now, this part of the equation can be splitted using the laws of indices. Therefore, we can write y equals to a exponential bx times exponential c. A is a constant, exponential c is also another constant. A constant times another constant is a constant, say d. Now, y can be written as d exponential bx. This one is a primitive equation with two essential constants, d and b. Now, having looked at some examples of primitive equations, now let's go ahead and form differential equations using these primitive equations. Example 1. Form the ordinary differential equation associated with this primitive equation, y equals to ax squared plus bx plus c. Now, as you can see, we have three essential constants. Therefore, we are required to differentiate 3 times. Let's start. dy over dx equals to 2ax plus b. d squared y over dx squared equals to 2a. Then the third one will be d cubed y over dx cubed equals to 0. This is the differential equation required. Example 2. Suppose we have y equals to ax plus a squared. In this equation, we only have one essential constant, that is a. Therefore, we will differentiate once. dy over dx equals to a. Now, we need to substitute the value of a in the original equation. Therefore, we have y equals to x dy over dx plus dy over dx squared. This is the required ordinary differential equation. Example 3. Suppose we have y equals to ax plus bx plus c. As you can see, a and b can be factored out, so we can have a plus b We put them in brackets, x plus c. A is a constant, b is a constant. So a constant plus a constant gives us another constant. Therefore, we can say let a and b, a plus b be equal to d. So we have dx plus c. Now this primitive equation has two essential constants, d and c. Therefore, we are required to differentiate it twice. Okay, let's start. Dy over dx equals to d squared y over dx squared equals to 0. This is the required ordinary differential equation. Example 4. Suppose we have y equals to a cos x plus b sin x. Now, as you can see, we have two essential constants, a and b. Therefore, we are required to differentiate this equation two times. Let's start. Dy over dx equals to, when you differentiate cosine, you get negative of sine, plus when you differentiate sine, you get positive cosine. Again, when you differentiate sine, you get positive cosine. And when you differentiate cosine, you get negative sine. When you look at this equation carefully, you will realize that equation 3 is the same as equation 1, only that the sign has changed. Therefore, d squared y over dx squared is equal to minus y, meaning d squared y over dx squared plus y equals to 0. This is the required ordinary differential equation. Now, the last example, that is example 5. Suppose we have y equals to a exponential 2x plus b exponential minus 2x. Now, because we have two essential constants, we are required to differentiate this equation twice. Let's start. Dy over dx equals to 2a exponential 2x minus 2b exponential minus 2x. D squared y over dx squared equals to 4a exponential 2x plus 4b exponential minus 2x. Let's factor out 4. So we have 4 into a exponential 2x plus b exponential minus 2x. Now, if you look at this component and this one here, they are the same. Therefore, we can substitute this value over here with y. So, d squared y over dx squared is equal to 4y. We can also write it like d squared y over dx squared minus 4y equals to 0. This is the required ordinary differential equation. Thank you for watching.